this is a work I published in December 2023 with Valérie Detrenton, Gilles Guette, Frédéric Ayori, and Damien Crémieux. And it is about CVE representation to build attack positions graph. So basically, a vulnerability is defined by the NIST, Institute for Standardization that work in cybersecurity, among others. This is a weakness in an information system that could be exploited or triggered by a threat source. Regularly, security audits can help to discover vulnerabilities in the information system. Here, for example, we have two machines. One machine is vulnerable to two CVE vulnerabilities, and another one is vulnerable to another vulnerability. And on the right side, we have a Nessus screenshot. So Nessus is a security scanner, and he helps to uncover the fact that vulnerabilities are present on the machines. So here we have the ID of a vulnerability. 2021 is the year of the publication, and then the unique identifier of the vulnerability. So when we know vulnerability with a given CVE is present, what we want to know next is more information. What else with this vulnerability? So on the national vulnerability database, we have a short textual description in the natural language of the vulnerability. We also we can have the CPE, so Common Platform Enumeration, and it says what is vulnerable to what is affected by this vulnerability. So here, for example, this vulnerability affects Azure Sentinel software that is provided by Microsoft. We have the CWE related to the vulnerability. So this is the weakness, the general weakness that relates to the vulnerability. And we can follow MITRE links to have a bigger overview at different scale. So this we can have the attack pattern, the attack technique, and even attack tactic that is related to the vulnerability. We also have the CVSS. So this is a common vulnerability scoring system, which gives an idea about how critical the vulnerability is based on a vector that has different components. So, for example, the CVSS gives us the attack vector that is local for this example, and we also have the privilege required to exploit the vulnerability that are low and can be medium or high. And finally, we have exploits that's related to the vulnerability. So this is a proof of concept code that can trigger the vulnerability, and they can be found on Metasploit and on ExploitDB. So here, for example, the vulnerability identified by CVE 2021-44-22-8, which is also known as Log4Shell, is an injection vulnerability that can allow an attacker to have a remote code execution. When the vulnerability is present, the attacker have full access to the machine where the vulnerability is present. And this is possible from anywhere in the world, remotely. And our question was, how can an attacker exploit the CVE and exploit multiple CVEs in a whole attack scenario? So to answer this question, we rely on previous work from other PhD students that are in the team. And we took the concept of attack scenario represented as a graph of attack positions. So attack positions are the nodes of our graph, and they represent the fact that the attacker is able to control one account on one machine, and then the edges show how an attacker can move from one position to another. For example, he can perform lateral movements when he keeps controlling the same user, but moves to a different machine. Or he can perform gather information and stay on the same with the same account on the same machine, but increase his knowledge of the information system. And finally, he can perform vertical movements, so he stays on the same machine, but gains control over a new user. So, however, CVE and the data we have when we are looking for information about the CVE, the CVE only is not enough, and the exploits related to the CVE give a lot of information about how it works. And in particular, it gives us information about where the attacker is located before the execution of the CVE, what are the privileges required for the attacker to exploit the CVE, where he will be the attack position after the CVE, and however, we don't have the resulting benefits about the CVE exploitation just by looking and understanding the exploits code. So our proposition was a format called CAPG, which means from CVE to attack positions graph. And it represents a pair of a CVE and an exploit. And it gives information about the constraints between the source and destination machines before and after the exploitation of the CVE, the source user, the destination user, and what are the constraints linking these two users. So we wanted to have, our goal would be to have multiple CVE represented in this format, and it would help us to build attack positions graph to understand how an attacker can chain CVEs. So now that we have an idea of what we want to, how we want to represent this CVE, the question is how do we populate this format? How do we represent the CVE in this format? So some fields are quite easy to compute. So the CVE is just the identifier of the CVE, that's the starting point. The exploits, the link to the exploit can be gathered using Metasploit, so it's a framework gathering different exploits. And we can use the command search CVE, and given CVE ID, it will return the related exploits. And the Vuln class that gives it can be found in the CPE related to the CVE to say whether it's a vulnerability affecting an application or an operating system, for instance. And here we have a screenshot of Metasploit console that can be used to find the exploits. The remaining fields require to execute the exploits to to understand what are the source and destination machines and users. So we have the exploits thanks to Metasploit. We also need an environment that is vulnerable specifically to the CVE. And to do so, we can use Decray that can automatically deploy a Docker container vulnerable to a given CVE. So, and then to determine the machine constraints, we will try to execute the exploits from the least restrictive environments to the most restricting one, and find what are the conditions, what are the least conditions required to exploit the CVE. So first, we have the machine vulnerable to the CVE. We try to exploit the CVE from totally a remote machine, but not correlated to the first one. If it succeeds, we know that there is no constraints between the machines, so we have constraints, and the machines are different. We can also, if it doesn't work in the first case, we can try the second case, where the two machines are in the same network or in the same LDAP domain or Windows domain. And if it succeeds, we know that there is a constraint, so machine can be different, but they must be in an adjacent network or in the same Windows domain. And finally, the most restrictive case is when remote exploitation is not possible, and we must have the source and destination machine must be are the same. So you can only exploit the CVE if you already have access to the vulnerable machine. About user source and user destination, and also user constraints. This is the similar process by trying to exploit from different users and then determining who is the user that is reached after exploiting the CVE. So in our example, we had two machines vulnerable to 2 CVE each. The first CVE can be exploited. It is located on M0, the first machine, the blue one here. It can be exploited. There is no constraint between source and destination machine. Any user can exploit it. The second CVE is also on M0, but it can only be exploited if you already have access to the machine. And you must be you can exploit it. So this is same machine for user machine source and destination. And about the user, you can exploit it. If you control a local user account, and you will reach a user that is system or root on the machine. And the third CVE, there is no constraints between source and destination machine, so it can be exploited remotely. And you go from a user that is only existing in an application to a user that exists on the machine. So we can imagine a case where we have different users' accounts existing on the two machines here. Tomcat is a machine that only exists on M0. And that it is the user that is executing an application Apache Log4j 2 that is vulnerable to the first CVE with the specific version 20.0. there is another user on M0 that is the user root that has high privileges. And there also is user Bitbucket that is an account that exists both on machine M0 and M1. So in an attack scenario, we can imagine with this knowledge that an attacker from any attack position, he can exploit the first CVE to gain control of the user uTomcat on the first machine. Then from this attack position, he can perform a vertical movement and gain control of user root by exploiting the second CVE. After gaining user account root, he can discover a new user on the machine that is uBitbucket, and with this account that exists on both machines, he can exploit the CVE, the third CVE, and finally gain control of a new machine. And this is we can derive these informations knowing the information system states and the source and destination machine that users as we represented them using the CAPG formats. So to conclude, our question was how to reconstruct a complex scenario from a list of CVE and some information about the user's accounts. Our main claim is the fact that CVE are not enough only. We need to describe them more precisely and understand what the CVE exploit can do. So we proposed to answer this challenge a format called CAPG to describe the attacker's propagation through the execution of multiple exploits. We propose a way to populate these formats by experimenting execution of exploits in a vulnerable environment in different conditions. And as future work, we plan to automate scenario reconstructions in larger scale environments and include this way to populate an attack position graph with CVE and other way to perform vertical and lateral movements. Thank you for your attention.